So this is a question which we were discussing in the last session. But before that, I will write the formulas again. That there are three formulas for moles. Number one, moles equal mass in gram divided by the molar mass. Molar mass means it can be atomic mass or it can be a molecular mass. That's the first formula. The second formula to get the moles, that is for solutions, moles equal concentration of the solution. So you have to learn or memorize this multiplied by volume of solution. That's the second formula which relate the concentration and the volume, but keep in mind the volume should be in decimeter cube. And the third formula which relate the moles of a gas with volume. So moles equal volume of the gas in dm cube divided by 24. So this is the third formula, but that is valid only for gases which relate the gases, the volume and with moles of a gas only. Now moving back to the question. So as you can see in this question, what is given to us, the equation is given, then student heated 10 gram of barium carbonate. So barium carbonate, which compound is barium carbonate, as we already discussed the formulas. So this is barium carbonate. So student is having mass of barium carbonate. What was the mass? That is 10 gram. And we need the moles. So how we can get the moles from the mass? So we will use the formula that moles equal mass in gram divided by molar mass. What about mass in gram? That is given 10. And what about the molar mass? For molar mass, you have to check the periodic table. So when you check the periodic table and find the mass of barium carbonate, so barium is 137 plus carbon is 12 plus oxygen is 16 multiplied by 3. So when you solve, you will get 197 as a molar mass or molecular mass. So molecular mass of barium carbonate is 197. So to get the moles, that is mass in gram divided by molar mass to get the moles. So mass in gram is 10 and molar mass we worked out by using a periodic table. So 10 divided by 197, that was 0.0508 moles. That is the first part. Now about the second part, we have to calculate the volume of carbon dioxide gas. So we have to calculate the volume of gas. So there is a formula which relates the volume of the gas. And what is that formula? That formula is moles equal volume of the gas divided by 24. That is a formula which relates moles with volume. That moles equal volume of gas divided by 24. So we need the volume of carbon dioxide, but we don't have the moles of carbon dioxide. So first what we have to do, we have to find the moles of carbon dioxide, and from moles of carbon dioxide we'll get the volume of carbon dioxide. Now how to get the moles of carbon dioxide? There is no information about carbon dioxide, nothing is given about carbon dioxide. So if the information is incomplete or nothing is given, what you will do, you will use a ratio. So whenever information is incomplete, we always use the ratio to get the answer. So first, we have barium carbonate that is given, and we want to find carbon dioxide. What is the ratio of barium carbonate to carbon dioxide? How many moles are there of barium carbonate in the equation? How many moles, or what is the mole number of barium carbonate in the equation? So in the equation you can see 1 is here. So 1, and how many moles of carbon dioxide in the equation? That is also 1. If you check carbon dioxide, this number is representing the mole number. So carbon dioxide also there is 1 mole. So this number before this element or compound represent the mole number. So according to equation, if there is 1 mole of barium carbonate, there should be 1 mole of carbon dioxide. But in the question, how many moles of barium carbonate are there? How many moles we worked out for barium carbonate? That is 0.0508. Then how many moles of carbon dioxide will be there? It will be X. So we cross multiply. So when we cross multiply 1 multiplied by X, that is X, and 1 multiplied by 0.058, that will give us 0.0508. So these are the moles of carbon dioxide. Is it clear till now? The second part, it's not complete. First, we are getting the moles of carbon dioxide to get its volume. Is it clear this till now, this part? To everyone? Now the second part, the main part, because we need the volume of carbon dioxide and the formula which relate moles with volume. Moles equal volume divided by 24. So moles of carbon dioxide are 0.0508. Volume we don't know. And divide by 24. If this 24 is divided, other side it will be multiplied. So 24 multiplied by 0.0508, that will give us 1.22 decimeter cube. So that will be the final answer. Is it clear? The volume of carbon dioxide. So we have the moles now. We multiplied by 24 to get the volume. Yeah, ratio always give us. How I get 1.22? As you can see, because the main question is find the volume, but we can use the ratio to get the moles. So after getting a moles of carbon dioxide, we need the volume. So moles of carbon dioxide are 0.0508. Volume of gas or volume of carbon dioxide we are finding, divided by 24. If 24 is divided, other side it will be multiplied. So 0.0508 multiplied by 24, when you multiply these two numbers, you will get 1.219, which is approximately equal to 1.22. So that's the volume of a gas in decimeter cube. How we got this 197? It is barium carbonate. So for barium carbonate, you have to use a periodic table to get the molar mass. As you can see, a periodic table, barium mass, we are finding the mass of barium carbonate. The molar mass means molecular mass here. So barium, when you check, it is 137. When you check carbon, it is 12. And oxygen is 16. So it will be 16 multiplied by 3. So this is 137 plus 12 plus 16 multiplied by 3 is 48. So when you add these numbers, 12 plus 48 is 60, and 60 plus 137, the sum will be 197. So molecular mass is 197. That's how we got the molar mass. So first what we did, we use mass in gram divided by molar mass. Using molar mass is by using the periodic table. So that is 0.0508. Then to get the volume, because we should have moles to get the volume, so always we can take the mole ratio. So you have barium carbonate and you are finding first moles to get the volume. The ratio is 1:1. So if 0.0508 moles are there, then X moles of carbon dioxide, that is 0.0508 moles of carbon dioxide. And now you have the moles, the formula which relate the volume of a gas with moles. Moles equal volume of a gas divided by 24. So moles are 0.0508. Volume of the gas is unknown and divide by 24. This 24 is divided, other side it multiply. So 24 multiplied by 0.0508, that will be 1.219, which is 1.22. So that is how we got the moles for this carbon dioxide. Okay, another question. A student started with 20 cm cube of 0.02 mole per dm cube NaCl. Determine the amount used. Amount means the moles. As I mentioned here, we are finding the mole. So what we have, first thing you have to understand what is given to you. 20 cm cube, what is this? Concentration or volume? 20 cm cube. Which quantity is this? 20 centimeter cube. Centimeter cube, meter cube, decimeter cube. These are all the units for volume. So this is a volume which is 20 cm cube, and 0.2 mole per dm cube. 0.2 mole per dm cube is the concentration. So concentration is 0.2 mole per dm cube. But whenever volume, most of the question, the volume is given in cm cube. So you have to convert into dm cube. So if I want to convert the volume into decimeter cube, what I should do? Divide by 1000 or multiply by 1000? Centimeter cube to decimeter cube. So I'll divide by 1000. So 20 divided by 1000, which is equals to 0.02. Now we need the moles. So we have the formula moles equal the concentration multiplied by volume. In dm cube, the concentration of solution is 0.2 and the volume is 0.02. So when you multiply, it will be 0.004. Is it clear? This question, how we got the moles from concentration and volume? Okay, another question, a similar question. In an experiment, 25 cm cube of sodium hydroxide. So this is sodium hydroxide. 0.4 mole per dm cube was neutralized or reacted. You can use the term neutralized or reacted with 20 cm cube of oxalic acid. So oxalic acid is, this one is oxalic acid and here is sodium hydroxide. we have to calculate. This is the main objective, but it's not like directly you will get this final answer. You have to follow the steps given in the question to get the final answer. So the finally we have to calculate the concentration of oxalic acid. That's the main, that's the final objective, but you have to follow the steps which are given in the question. The first part, calculate the moles of sodium hydroxide in 25 cm cube and 0.4 mole per dm cube solution. So we have what we have for sodium hydroxide, 25 cm cube. What is this? 25 centimeter cube. That is the volume, and 0.4 mole per dm cube is the concentration. But that volume, because it is in centimeter cube, we have to convert into decimeter cube. So what we do to convert the centimeter cube into decimeter cube, we have to divide by 1000. So concentration, the volume will be 25 divided by 1000, which is 0.025. So I need the moles. So if I have volume and I have concentration, so what I can use a formula that moles equal concentration into volume. So concentration is 0.4 and the volume is 0.025. When I multiply them, I'll get 0.01 moles. Is it clear, the first part? We got the moles of sodium hydroxide. Now the second part, use your answer and the mole ratio. Mole ratio means you have to use the ratio to get the answer. So they give, sometimes they give you the hint in the question that you have to use a ratio. So what ratio we will use, because we already worked out the moles of sodium hydroxide. So sodium hydroxide we already worked out, and we need the moles of oxalic acid, which is C2H2C2O4. So when you check the equation, what is the ratio between sodium hydroxide and oxalic acid? How many moles of sodium hydroxide according to equation? So how many moles are there for sodium hydroxide according to the equation? That's 2. And how many moles of oxalic acid CH2C2O4 according to equation? Because nothing is written, it means 1 is there. So 2:1 is the ratio between them. How many moles of sodium hydroxide are there? We worked out in the previous part. If we have 0.01 moles of sodium hydroxide, how many moles of oxalic acid will be there? X. So we cross multiply. So when we cross multiply, this will be 2x is equals to 0.01. We need x, so x is equals to 0.01 divided by 2. So x is equals to 0.005 moles of oxalic acid. Is it clear? The second part. Getting the moles of oxalic acid. As in the question, they mention that you have to use a mole ratio or ratio between oxalic acid or ratio of the oxalic acid with other substance to get the moles. So sodium hydroxide is there with us, and we've got the moles for oxalic acid. Anyone having a question or a doubt in the second part? Then the third part, we need the concentration. So the formula to get the concentration, because the concentration, the volume, it can only be found by using a formula. So you have the formula which relate concentration, that moles equal concentration into volume. So we have the how many moles of oxalic acid. I told you that in the moles the questions are interrelated. So how many moles we got for oxalic acid? We got 0.005. So 0.005 moles of oxalic acid concentration we are finding. And what is the volume of oxalic acid? The volume of oxalic acid is, how much oxalic acid is there? 20 cm cube. So 20 cm cube means it should be in decimeter cube. So divide by 1000. So it will be 0.02 decimeter cube. We need a concentration. If volume is multiplied, other side it will divide. So 0.005 divided by 0.02. So the concentration will be equal to moles divided by volume. And moles for oxalic acid 0.005 divided by volume is 0.02. So 0.005 divided by 0.02, which is equals to 0.25, and the unit of the concentration is moles per decimeter cube. Is it clear, this third part? Yes, Abdullah Sarfraz, Abdullah Khan, Heather. Any doubt? Yes, Abdullah Sarfraz, Abdullah Khan, Heather. Anyone of you having a doubt or a question related to this? Okay, in this question, in an experiment to find the maximum volume of oxygen, so we have to find the volume of oxygen, the maximum volume of oxygen basically produced, that is 96 cm cube. That's a volume of oxygen or volume of the gas which is measured at room temperature and pressure. We have to calculate the concentration of hydrogen peroxide solution which is used. The first part, the number of moles of oxygen formed. So how to get the moles? If we have the volume of the gas, so formula moles equal volume of the gas in decimeter cube divided by 24. That is a formula which relate the volume with the moles. So volume of the gas in decimeter cube, this is given in cm cube. So again we have to convert into decimeter cube, divide by 1000. So 96 divided by 1000, that is equals to 0.096. So 0.096 divided by 24. So when we divide them, we'll get 0.004. So number of moles of oxygen formed, that is 0.004. That's the first part for which we use a formula to get the answer. As the volume of the gas is given and we need the moles. Now about the second part, the number of moles of hydrogen peroxide. So in 40 cm cube, so we have the volume of hydrogen peroxide, but we can only, because it's a solution, for solution we cannot use this formula. It is only valid for gases. So if it is a solution, to get the moles we need concentration and we need volume, both of them, because when we multiply both of them we'll get the moles. But here we have the volume of hydrogen peroxide, but we don't have concentration, so we cannot use a formula. If we cannot use a formula, then we can simply use a ratio. And what ratio we can use? Because we already worked out oxygen. So we worked out oxygen. So the ratio between hydrogen peroxide, which is H2O2, and oxygen, that is 2:1. So the simplest ratio between them is 2:1. Then if we have 0.004 moles of oxygen, how many moles of hydrogen peroxide will be there? X. So we cross multiply, 2 will be multiplied with 0.004 and X is multiplied with 1. So we'll get 0.008. Because it's a cross multiply, so 0.004 multiplied by 2 and X is multiplied by 1. So it will be X is equals to 2 multiplied by 0.004. So X will be 0.008. So using the ratio, we got the second part. And why we use the ratio? Because to get the moles of hydrogen peroxide, the information here is incomplete. We only have the volume of the solution. We don't have concentration. To get the moles, we should have both concentration and volume. So that's why we are not able to use a formula for second part. We use a ratio. Now about the third part, we need a concentration of hydrogen peroxide. So how to get the concentration? To get the concentration, the formula moles equal concentration into volume. The volume, the moles of hydrogen peroxide, that is 0.008. Concentration we don't know. And the volume of hydrogen peroxide is given 40 cm cube solution. So if it's a 40 cm cube, it should be in decimeter cube. So it will be 0.04 because we divide by 1000. And 0.04 is multiplied, other side it will divide. So it will be 0.008 divided by 0.04. So we'll get the concentration of this solution. So 0.008 divided by 0.04, which is equals to 0.2 mole per decimeter cube. Because this is 0.008 divided by 0.04. So we'll get the final answer as 0.2 moles per decimeter cube as a concentration. Is it clear, this question? Anyone having a doubt? Another question. Period 3 contain element sodium to argon. This question is about the chemistry of period 3 element and their compounds. So sodium nitrate, this is a compound. Sodium nitrate is a white solid. When we heat it, melt, and it turn into sodium nitrite plus oxygen. This is sodium nitrate, this is sodium nitrite. 3.6 gram of sodium nitrate is heated. Calculate the number of moles. So we have the mass in gram, we need the moles. So if we have the mass in gram and we need the moles, so we'll use a formula. Moles equal mass in gram divided by the molar mass. So we have the mass in gram, which is 3.40, but we don't have the molar mass. So how to get the molar mass of sodium nitrate? So you have to check a periodic table for this. So for sodium nitrate, mass of sodium is 23, nitrogen is 14, and oxygen is 16. So it is NaNO3. Sodium is 23 plus nitrogen is 14 plus oxygen is 16 multiplied by 3. So we'll add 16 multiplied by 3 is 48. That plus 14 plus 23. So the sum will be 85. So the molecular mass of sodium nitrate is 85. So we'll use the formula. So moles equal mass in gram divided by the molar mass. Mass in gram is 3.40 and the molar mass is 85. So 3.40 divided by 85 will get 0.04 moles of sodium nitrate. Is it clear, the first one, the first part? Yeah, that's right. 3.40 divided by 85, that's 0.04. Then the second part, we need the number of moles of oxygen. But as you can see, the whole question, nothing is given related to oxygen. So if information is incomplete or nothing is given, well, then what we do, we'll use a ratio. But which substance we'll take a ratio? Because we already got the moles of sodium nitrate. So we'll take a ratio between sodium nitrate and oxygen. So what is the ratio between sodium nitrate and oxygen? How many moles are there in the equation? If there are 2 moles of sodium nitrate, there should be 1 mole of oxygen. So ratio between them is 2:1. But in the question, we don't have 2 moles. In the question, we have 0.04. So if we have 0.04 moles, then how many moles of oxygen are there? X. We cross multiply. So 2 multiplied by x, that will be 2x, is equals to 0.04 multiplied by 1, it is 0.04. We need x, the mole, so 0.04 divided by 2. So how many moles we get? We'll get 0.02 moles. That is the second part. By using a ratio between sodium nitrate and oxygen, we got the moles of oxygen involved in this reaction. And the third part, we need the volume. So how to get the volume? There's a formula to get the volume related to moles. So moles equal volume of the gas divided by 24. So moles, how many moles are there? 0.02. Volume of the gas is unknown and divide by 24. If 24 is divided, other side it will be multiplied. So 24 multiplied by 0.02. So we'll get 0.48 decimeter cube of oxygen. Is it clear? The 3 parts related to moles. So first one, we use a formula. The second one, we use a ratio. And the third one, we again use a formula. So normally the trend of the question is like this. If normally the simple trend is like formula, ratio, formula. It's a simple trend. Normally the trend is like this. Like first part you're solving by a formula, second part is by ratio, and third part is again by formula. As you can see in the previous question, so if you see, to solve the first part, we use a formula. To get the second part, we use a ratio. Then to solve the third part, we use a formula. Same way, this is related to another question, the same way, this question which we already solved. So to solve the first part, we use a formula. To solve the second part, we use a ratio. To solve the third part, we use a formula. So general trend is there that first part is solved by a formula, the second part is solved by a ratio, and the third part again solved by a formula. This is a general trend. I'm not saying it's always like this, but most of the question you will find that it is a trend. So when we solve this question, first we use a formula, then we use a ratio, and then again we use a formula. So these are questions related to topic moles. In the next session, we'll do more questions related to the moles. Any question or a doubt related to the class today? So there will be a past paper session, a short session, in which I will discuss a question from the past paper. So everyone should be there in that last session as well.